Hi, so for today we are going to talk about proof of solutions of differential equation. So basically, we're going to solve some uh, solutions here, proving that that is a solution of the differential equation. So let's recall what are the two kinds of solution of ordinary differential equation. So we have a general solution, and of course, we have a particular solution. So, what is the difference between the general solution and the particular solution? A general solution is a solution containing the number of arbitrary constants equal to the order of the ODE or the ordinary differential equations. So basically, general solution is a type of solution of differential equation in which the arbitrary constant is not defined, or the arbitrary constant does not have a specific value. But for particular solution is a solution obtained from the general solution by giving a particular values to the arbitrary constant. So meaning the arbitrary constant in a particular solution is already defined. Okay, so but we will be trying to prove, okay, to prove some of the solution of the differential equation. And let's see if that is actually a proof of solutions of differential equation. So number one, let us prove that y equals c e raised to 2x is a solution of the differential equation y prime 2y. So what are we going to do first? So we have to prove that this y equals c e raised to 2x is a solution of the differential equation y prime to y. So we need to get the y prime in order to substitute it here in our equation and to prove that they are equal. So let's try y prime. So we are going to differentiate this with respect to x. Okay? So what happens is that if we are differentiating e raised to through x, we are differentiating this function with respect to x. So in that case, that is 3 and copy the original function. So that's the differential. This same rule we apply. So having c as our constant. So what will happen is that 2c e raised to 2x. So that would be the y prime of this y. So what are we going to do after doing that? We simply substitute it and prove it that they are equal. So we have y prime. So I have to write y prime 2 sub c or 2c e raised to 2x equals twice or 2y, which is our y is c e raised to 2x. So obviously, they are equal. Hence, okay, therefore, y equals c e raised to 2x is a solution to that differential equation. Okay, so that's how we prove the solution of a differential equation. So let's try now number 2. So for number 2, we are going to prove that y equals c sub 1 cosine 2x plus sine 2x is a general solution of the differential equation y double prime plus 4y. So we have y equals c sub 1 of cosine of 2x plus c sub 2 of sine of 2x. Okay? To prove that that is the solution of y double prime plus 4y equals 0. So again, we have y double prime, so we have to get y prime first. Differentiate c sub 1 cosine 2x. So what happens is that if we differentiate cosine 2x, that is simply negative sine 2x. And we have to differentiate the inside function with respect to x, and that is 2. So basically, it's negative 2 sine 2x. But in this case, we have a constant. So what will happen? We have negative 2 c sub 1, okay, sine 2x. Okay? The same thing that we are going to do here. So this would become plus because sine 2x, the derivative of that would be cosine 2 cosine 2x. So 2 c sub 2 cosine of 2x. Again, the way we differentiate sine 2x is actually what? differentiate it as a whole, we have cosine 2x multiplied by the derivative of the inside function with respect to x. So the derivative of 2x is 2. So hence we have 2 cosine of 2x. But we have c sub 2, so we have 2 c sub 2 cosine of 2x. That is only the y prime. How about the y double prime? Again, if we get the double derivative or the second derivative, same process, we apply here. So this becomes cosine again, cosine of 2x, and then differentiate the inside function 2x. This becomes 2 cosine 2x multiplied by negative 2c sub 1. So it will become negative 4c sub 1 cosine of 2x. And of course, the same thing happen here. It's just that this cosine would become negative because a derivative of cosine would be negative sign. So this would be multiplied again to 2. So this becomes 4c sub 2 sine of 2x. So the negative sign, we place it here. Okay? Because of the derivative of cosine. So now we have y prime, we have y double prime, we have y. We can substitute it to our differential equation and let's see if that will equate to 0. So we have y double prime. So writing the y double prime plus 4y equals 0. So substituting. So we have negative 4c sub 1 cosine of 2x. We have the y prime. Substitute minus 4c sub 2 sine of 2x plus 4 multiplied by y. Here is our y, the original solution. So we have c sub 1 cosine of 2x. Okay. And then we have plus. Then we have plus c sub 2 sine of 2x. Okay. Equals 0. So obviously, this is for c sub 1 cosine 2x minus 4c sub t sine 2x. If we're going to multiply or distribute 4 here, so that becomes 4c sub 1 cosine 2x. And then we have plus 4c sub 2 sine of 2x. Obviously, this would cancel. Negative 4c sub 1 cosine 2x will be cancelled by the positive 4c sub 1 cosine 2x. And the negative 4c sub 2 sine 2x will be cancelled by positive 4c sub 2 sine 2x. So definitely, right side of the equation equals the left side of the equation. 0 equals 0. Then definitely that is a solution. Okay? So this is, we have proved that this y equals c sub 1 cosine 2x plus c sub 2 sine 2x is a solution of the y double prime, okay, plus 4y equals 0 differential equation. So number 3, we have to prove that y equals, it says, ln cosine x minus 1. So ln of cosine of x minus c sub 1 plus c sub 2 is a solution of what? Y double prime plus y prime squared plus 1. So y double prime plus quantity y prime squared plus 1 equals 0. So basically, we're going to get the second derivative of our solution. So first one, we get the derivative of this ln cosine of x minus c sub 1, considering c sub 1 and c sub 2 as constant, and we are differentiating with respect to x. So how do we get the derivative of an ln? We know that that would be 1 all over x, okay? Or the dx all over x, okay? So that's how we get the derivative of an ln. So we differentiate this, okay, with respect to x, so that becomes negative sine of x minus c sub 1 multiplied by the derivative of the inside function of the cosine with respect to x. So that becomes 1. Okay, because the derivative of x is 1, derivative of constant is 0. Divided by its original function x. So what's the original function? Cosine of what? X minus c sub 1. Okay? Plus, the derivative of c sub 2, which is a constant, would be 0. Okay, so again, if we are going to recall, sine over cosine, so we have sine of x all over cosine of x equals tangent of x. Or sine theta all over cosine theta is tangent of x. So we can further simplify it by trigonometric functions. So we have, since this is negative, so this becomes negative tangent of x minus c sub 1. Okay, that is the simplification of our y prime. And then, now we are ready to get the y double prime. So, with respect to x, differentiate this again with respect to x. So, we have set aside negative here. The derivative of tangent is secant squared of x minus c sub 1. So, y double prime, we have negative secant or secant squared of x minus c sub 1. So, here we go. We now have the y double prime. We can substitute it with our differential equation and see if this is a solution to our differential equation. So, how do we do that? Y double prime. What is our y double prime? Negative secant squared x minus c sub 1. Okay, here is that. Then plus quantity y prime. What is our y prime? This one, this negative tangent. So, negative tangent of x minus c sub 1 squared. Don't forget the squared here. Okay, and then plus 1 equals 0. So, simplifying, we have here, okay, if we square this becomes positive. Okay, tangent of squared of x minus c sub 1 plus 1 equals 0. So it seems like that it does not equate to 0. But wait, recalling the identity of the Pythagorean, wherein we have tangent squared theta plus 1 equals secant squared theta. So this tangent squared x minus c sub 1 plus 1 is this term. So technically, this term, okay, this tangent squared of x minus c sub 1 plus 1 is technically equal to secant squared of x minus c sub 1. So, substituting it to our formula or to our solution will give us negative secant squared of x minus c sub 1 and then this term plus secant squared of x minus c sub 1 equals 0. And we know that these two, since they have different sign, would really cancel. So, hence, this is a solution to our differential equation. Okay? How about number 4? Okay, let's try. To prove that y equals c sub 1 e raised to 2x plus c sub 2 e raised to negative 3x is a solution to y double prime plus y prime minus 6y equals 0. So we're going to prove that this y is a solution of our differential equation right here on the right side. So same thing that we are going to do. We get y prime first, okay, before y double prime. So we have to differentiate this again, okay, by each term. So we have 2c sub 1 e raised to 2x, and then we have, since this is negative 3, so this becomes negative 3c sub 2 e raised to negative 3x. So that's the first derivative. For the second derivative, since we need that because of our differential equation here, y double prime, so applying the same rule, this becomes 4c sub 1 e raised to 2x, and negative 3 times negative 3 because of the derivative of this, so this becomes positive 9c sub 2 e raised to negative 3x. And substitute it now to y double prime plus y prime minus 6y equals 0. So y double prime would be 4c sub 1 e raised to 2x, okay, plus 9c sub 2 e raised to negative 3x plus y prime. Here is our y prime. So 2c sub 1 e raised to 2x minus 3c sub 2 e raised to negative 3x. That is our y prime. And finally, minus 6 times the y, which is this y. So we have c sub 1 e raised to 2x plus c sub 2 e raised to negative 3x equals 0. Okay? So we can simplify this c sub 1 and this c sub 1. So 4 c sub 1 e raised to 2x plus 2 c sub 1 e raised to 2x. That becomes 6 c sub 1 e raised to 2x. We can also simplify 9 c sub 2 e raised to negative 3x minus 3 c sub 2 e raised to negative 3x. So that becomes plus 6. Okay? c sub 2 e raised to negative 3x. And we are going now to what? Distribute negative 6 on this term and this term. So what happens is that this becomes negative 6 c sub 1 e raised to 2x. Don't forget the sign. So we have negative 6 c sub 2 e raised to negative 3x equals 0. So as you can see, 6c sub 1 e raised to 2x would be cancelled by negative 6c sub 1 e raised to 2x. The same as for the 6c sub 2 e raised to negative 3x and negative 6. So our answer would be 0 equals 0. And hence, it is a solution to our differential equation. Okay, this one is a solution. So we have verified once again. Okay, so let's try again number 5. Let's try number 5. So for number 5, we have y equals c sub 1 e raised to 3x plus c sub 2 of x plus c sub 3 to prove that this is a solution to the differential equation y triple prime minus 3y double prime equals 0. Okay, so we have y prime first. So this becomes 3c sub 1 e raised to 3x. Okay, plus, with respect to x, we differentiate this. This becomes simply c sub 2. And this c sub 3 becomes 0 because a derivative of constant is 0. So y prime would be 3c sub 1 e raised to 3x plus c sub 2. So how about y double prime? Because we need to get the triple prime. Okay? So y double prime would be 9c sub 1 e raised to 3x plus derivative of c sub 2 would be constant or 0. So we have 9c sub 1 e raised to 3x for our y double prime. How about for triple prime? We have y triple prime. Oh, it's very simple. We have 27c sub 1 e raised to 3x. Okay. So we get now the y triple prime, the y double prime, and the y prime, and we have the y. So it's now time to substitute. Okay? 2y triple prime minus 3y double prime. Okay? In our equation. So, y triple prime is equal to 27c sub 1 e raised to 3x. 27c sub 1 e raised to 3x minus 3y double prime of the y double prime. Our y double prime is 9c sub 1 e raised to 3x equals 0. And obviously, okay, if we are going to transpose this or distribute negative 3, that would be negative 27c sub 1 e raised to 3x equals 0. So 0 equals 0, then therefore a solution. Okay, so we have proved that that is a solution to our differential equation. Okay, so I leave you with an assignment, okay? And see for yourself if this prove, okay? Prove it. Okay, for number 6, you prove if this is a solution to our differential equation. C sub 1 e raised to x plus c sub 2 e raised to 2x plus c sub 3 e raised to x. Prove that is a solution of y triple prime minus 6y double prime plus 11y prime minus 6y equals 0. So, prove, is it a solution or not a solution? Solution or not a solution? Okay. So, same process. You get the triple or third derivative of this. Okay, because you have y triple prime here and substitute all the values of y triple prime and then y double prime, y prime, and y. Okay, and see if that equals to 0. So if that equals to 0, therefore that is a solution. If that would not equal to 0, then that is not a solution. So see for yourself. Try it. So the only way for you to really understand it is to do it yourself. Okay, so it's very easy if someone explaining to you is uh, uh, you understand, okay, but you will know if you really learn something from this video if you do it by yourself. Okay, So, if you are new to my channel, please don't forget to subscribe and hit the thumbs up button and subscribe to my channel. So, thank you so much for listening. I hope you learned something for today's video. Again, see you again on the next video. This is Engineer Abat, and thank you so much for listening. God bless us all.